My name is Jesse Haworth. I'm a 3D printing application engineer with Hawkridge Systems, and I'll be the main presenter for today's session on using the Markforged Blacksmith software to forge accurate 3D printed parts. So this is one of our shorter conference sessions, but just for a quick overview, we'll first be going over what the Blacksmith software is and how it fits into the overall Markforged ecosystem. Then, once we get through that, we'll be covering some of the benefits of the software and some reasons why users might choose to use this as an inspection solution. And of course, we won't just be showing only slides today, so we'll also be going through a quick demo of the software itself. And when we've got that all covered, we'll go through any unanswered questions that you all might have. So for anyone here who doesn't own a Markforged printer or isn't super familiar with Markforged as a whole, the company itself was founded in 2013 and was built on the question of what if we were able to make a printer that could create parts strong enough for end-use applications. Their headquarters is in Boston, and even though they do have a global presence, all of their hardware, materials, and software is designed and manufactured in the United States. Markforged mainly operates through a partner support model, which essentially means that they have partners like Hawkridge Systems sell and provide support or training for their products. Now, you'll notice that I did mention materials and software instead of just hardware, and that's because Markforged focuses on more than just building solid printers. They built their own print preparation software, which is called Eiger, and Blacksmith is actually incorporated into Eiger itself. Their software is also the only 3D printing software that has ISO 27001 certifications, which basically means that it meets some really high privacy and security standards. Markforged also develops and creates all their own materials. And because it's built for their systems, you can really easily swap to new materials into a printer without needing to mess around with stuff like temperature settings or feed rates like you would on a hobbyist machine, because Markforged does all that stuff for you. So moving on to one of the most important questions of today's session, what actually is Blacksmith? And while we go over that, I'm going to launch a quick poll here asking if anyone has ever needed to verify the accuracy of a 3D printed part before they actually used it. Now, from that poll and the actual title of this presentation, it's pretty easy to guess that Blacksmith is an in-process inspection software for the X7 Industrial Series printer. Now, what that means is that while parts are being printed, they are scanned every layer for accuracy. And because this happens while a part prints, users don't actually need to do anything during or after the fact in terms of additional input. For anyone who has seen or actually owns an X7 machine, you'll remember that the print head already has a laser micrometer built in, which is super useful for print bed leveling and calibration. Blacksmith actually makes use of this laser, so there's no hardware upgrades or anything like that to the machine itself. Every X7 is compatible with it. Now, when a part is scanned, Blacksmith actually stores the accuracy reports within Eiger for later viewing. This means that there's an actual verifiable paper trail for QCing 3D printed parts, and they don't have to be measured or inspected after they are imprinted, so they're ready to go right off the bed. Now, like I was just mentioning, Blacksmith requires no additional hardware upgrades to the X7, so how does the software actually work then? Well, the whole process is really simple, and it starts with making sure the laser is calibrated to scan parts. Now, this is done by placing a provided reference print bed on top of the normal print bed, and the print head laser then scans the bed automatically, and it calibrates itself while doing so. This is a one-time deal unless you move the machine or change to a different print bed for whatever reason. And the calibration only takes about 30 minutes, with the only user input being starting and closing out of the calibration utility after it's complete. We'll go over this part in a bit, but the next step in the process is importing parts into Eiger, like you normally would do before a part is printed, and then toggling Blacksmith to scan them. When a marked part is printed, the printer will scan it, and Blacksmith will compare the geometry of each layer to that location on the original part file. And lastly, the history of reports for that file are stored in Eiger so that they can be referenced at any time after the part is printed. So that all sounds simple enough, right? But what are the actual advantages to someone using Blacksmith? Why would you use this? Well, the easiest one to see is that it removes any quality control process from the equation of getting a part from printer to application. The last 18 or so months have really shown how important turnaround time can be. And if you have printed parts immediately going to a quality control queue, which could be backed up with other parts already, then you aren't really getting the full benefit of a printer. And another point here is that there hasn't ever really been a standardized process for quality checking critical dimensions of 3D printed parts. So some companies have them measured with calipers, some companies scan them, but it all takes time and the process might miss a critical piece of geometry. 3D printing adds another layer of complexity to quality control too, because even if there's a quality control process already in place, if parts get mixed up with each other, there's no real way to guarantee that they all have the same internal print settings like fiber or infill percentage. Blacksmith is extremely useful on this end because parts are locked before being printed, which means their settings can't be changed in any way. So in turn, this means that each follow-up of that same part already has documentation that no print settings have been altered. Now, each time a blacksmith part is printed, the scan report is timestamped and archived. So if someone in your organization, say, wanted to view past reports, it's really easy to either download a scan report and send it to them, or just give them access to Eiger and let them view scan history if that's feasible for you. And like I mentioned earlier, Blacksmith scans each layer of a part, so there's no chance of missing measurements on a critical dimension or piece of geometry like you might if someone was measuring them by hand. Now, Blacksmith does also have different scan settings, because if you're printing something like a soft jaw, you probably don't need to scan at the highest resolution, because there's not usually any small features on something like that. So if you need to save a few minutes and get a part out the door, but you still need to scan it, you have that option. All right, so I've gone over enough slides, so let's go ahead and take a look into how Blacksmith works on the software side. So I've switched over to Eiger, and here we have an STL of an impeller part. For anyone who hasn't used Eiger before, it's really simple to use, and Blacksmith really doesn't change that trend with it being a slider to toggle on and off for parts. So I'll go ahead and do that here, and when I turn on Blacksmith, you can see that the option for those scan resolutions I was talking about pop up. I'm going to go ahead and set this to high, and then slice the part, and the scanning is automatically added while the part is being sliced and path as we speak. So just as a reference, the medium resolution scan that this part was set at first was about 19 minutes of added scan time on top of the print time. And once this is done, you can see that adding even high resolution scans doesn't really have a huge impact on print time, with this being about 36 minutes of additional time here. Okay, so now the part is marked for scanning, and we would be able to print it just like any other part, but we're going to go the daytime cooking show route and skip that part so we can go to the Blacksmith scans area. So over here on the left, you can see there's two areas. The first is parts, which is basically just every part that has been toggled for Blacksmith scanning. And then there's builds, which is parts that have actually been printed and scanned. So we've printed that impeller part with Blacksmith, like I said. So I'll open it here so that we can take a look at what you actually see with Blacksmith. Now, because Blacksmith exists within Eiger, you'll see some familiar information, and the navigation controls are the same, just mouse wheel zoom in and out. But you can see that the part is covered in a bunch of scan points showing the deviation of that area of the part. If I want to filter for specific accurate results, I can do that with this deviation bar. So let's filter for results that deviate by 135 microns, which is a bit over 5 thou. And you can see what points on the part are above that range and what percentage of scan points that is, which is really low for this part. And I can change what I'm looking for really easily, filter for different results if I want to as well. If I don't want to view signed results, I can change it to absolute and then filter those results in the same way too, whichever is easiest for the user to look at. And same as the sign results, I can filter for areas that are outside of a specific accuracy really easily, and then rotate the part to get a better look at my geometry and those results. You can also filter by the surface deviation of your geometry if scan points isn't what you need, and filter those results the same way that you would with scan points, So basically, it's really easy to find what you're looking for in a way that's easy for a user to interpret. This is a little bit much to look at, so for now I'll just switch back to what we initially had set with the results displayed as, which was signed scan point deviation. Now, one other mode that Blacksmith has is for part inspection. And what this does is it allows you to look at a bunch of information for a particular surface, which is really helpful if you have something like a hole that you need to know the accuracy of. You can also compare different surfaces as well. I'll just click on a few here, which could be useful for something like comparing the diameters of two holes, inner or outer diameter, or the difference between two similar shapes. And then Blacksmith also gives you a bunch of useful info like the surface area or standard deviation for whatever surface you select. And if you do accidentally select a surface, you can just remove it from the list here on the right-hand side. I'll just go ahead and remove these surfaces that I just selected here. Now, probably the most important part of Blacksmith is being able to export these results, because it might not always be feasible to have the QC staff as part of your Eiger 3D printing organization. These reports are huge because not only do they list the part name, how much material was used, and the exact print settings, but they also list process control stuff like what exact machine the part was printed on and what timestamp the print finished. A lot of the deviation data that I was just showing is in these reports as well. And if you do have multiple prints of the part, each of their scan reports can be accessed through the timestamp drop-down menu, which I have selected here at the moment. Okay, so we've gone over a bit about Blacksmith and how it's a really, really good tool for actually verifying how accurate a part is, and how, in general, it's a really great solution for just getting printed parts to their application faster. But Markforged is actually going to take this one step further. And with Blacksmith, they will be incorporating machine learning so that the printer will be able to identify geometry or areas of a part that might be out of spec and adjust print settings for follow-up attempts. And like I was showing, each of those reports will be accessible, so you'll be able to document and verify really easily what areas of the parts are becoming more accurate. And right now the software is being used on the Markforged X7, but they do want to bring it to the level of verifying Metal X parts as well, which is going to be a massive help for getting fully 3D printed metal parts into the hands of users quickly without sitting in a quality control queue or something like that. Well, I do want to thank everyone for their time here today. Like I said, this was a shorter session, and it looks like we have a few minutes left. So let's go ahead, and if anyone has any lingering questions that were answered, let's go ahead and get through them. Also, looking at this poll, most of you do at least some sort of quality verification or geometry checks at some point with your 3D printed parts. So if you're interested in any more questions or a demo or anything, then feel free to let us know.